All right, in this video, we'll be implementing this amazing project. What exactly it is? It's an end-to-end implementation of Azure three-tier architecture using Terraform. As you can see, it has a lot of components, a lot of infrastructure and networking services that we have used. But why are we doing this? We are doing this because, a lot of time you have mentioned in your resume that I have implemented this in Azure, I have implemented that in Azure, but you are not actually able to explain it properly to the interviewer, and it end up having a negative impression on the interviewer. Now if you follow this video, if you implement this end to end by all the best practices that I'll be mentioning, your interviewer will be impressed. I can guarantee that. Now there are a lot of pieces. As you can see over here, we have app gateways, we have web application firewall, public private subnet, internal load balancer, database in multi-AZ setup, Azure NAT gateway. I will try to explain each and every component and the significance of each of these. Why are we using this? And what else you can do on top of it. So in this video, we'll be looking into this architectural diagram in depth. Then we'll see the Terraform code that I have written for you, and it uses custom modules of Terraform, which is again one of the best practices and something that you don't see in a lot of YouTube videos these days. And then I will also do the demo of implementing it, and by deploying a sample three-tier architecture based application on it, which has a database, front end, back end components to it. And I will also share my tips and tricks how you can elevate this to the next level to stand out in the crowd, right? So yes, this is a complete project, but specific to Terraform, which is infrastructure as a code, and from infrastructure and networking perspective of Azure. But then you can do a lot of things in on top of that to make it one single capstone project that you can add in your resume and explain it end to end to the interviewer. And I'll explain that later on in this video. So for now, if you are new here, hi, my name is Piyush, and I have been in IT for past 13 plus years. I have been teaching cloud and DevOps in my channel for past 4 years, and I have tutorials on each of the clouds like AWS, Azure, GCP, and everything about DevOps, Kubernetes, and a lot more. You can browse through the channel. And this is like I'm just giving the introduction if you are new here. And I have also noticed a lot of you have been watching the video but not subscribing the channel. Please don't do that. It's just a click away. So please support the channel so that I keep on producing such amazing videos. I just had this request. Make sure you implement this project end to end. Not just watch the video, not just follow along, but implement it end to end, and then you will feel a lot better. You will have a lot of confidence after the implementation. Yes, it will involve some cost to it, and if you keep it running, I'm sure you will be flooded with a lot of cost. So don't do that. Make sure you destroy the infrastructure once you are done with the demo. If by any chance you have some constraint about the cost and everything, you are not able to afford it, then you can just follow along the video, because I will explain it everything end to end. Okay, so yes, enough about the introduction. Let's dive deep into it. Okay, as you can see, it's a three-tier architecture. What's a three-tier architecture? It has a presentation layer, or the front end web tier, which is also a front end. Then it has an app tier where your business logic resides over here. And then it has a database tier where your database resides. Now, we separate these layers so that we can have different set of networking rules, different set of logic, and different way of accessing these servers, right? Because you don't want your let's say public instances or your front end instances to have same level of access as your database instances, right? Database instances should be kept private within a secure zone and all those things, right? So that's why we have to separate those in different subnets, different tiers, and so that we can implement a lot of things on top of that, and we'll look into those things as well. Now um, what we have is over here is a user. Okay, and everything that we see over here is part of a single resource group. And then we have a virtual network as well. The Terraform component is not here in this diagram, but this is how our infrastructure will look like. Okay, so we have everything in a virtual network. We have created a virtual network, and then we have created separate subnets. Okay, so we have two public subnets where our front end application servers will be there. We have two private subnets where our business logic will be there, or the application will be running the backend application. And then we have subnets for a database tier. Okay, so user will send the request to app gateway, which is an external facing load balancer. Okay, and it is secured by web application firewall or WAF. Okay, it helps you with DDoS attacks and a lot of presentation layer attacks. Okay, and you can set certain rules to it. It's basically to secure your application from the front end itself. Okay, then it has a public IP because it has to be accessible over the internet. So there's a public IP attached to it. Now it will be part of an app gateway subnet. It's a separate subnet. Then the request will be redirected to the front end instances. Okay, these two front end instances are two virtual machine behind virtual machine scale set. Okay, what is virtual machine scale set? Virtual machine scale set is nothing but a group of identical virtual machines. Okay, just like in AWS, if you have worked with AWS, in AWS it is auto scaling group. If you have worked with GCP, in GCP it is managed instance groups or MIGs. So the same way in Azure we have virtual machine scale sets, which is VMSS, and it has the identical virtual machines. So let's say if this virtual machine goes down, then the virtual machine scale set will provision another machine with the same image, same specification, and same template. Okay, it has a template attached to it. So that's the benefit of it. It helps you create a highly available and fault tolerant infrastructure. If this goes down or the entire subnet goes down, you have your virtual machine in another subnet and it will provision a new virtual machine, right? Now we also have containers running. So the application that will be deploying, those application will be actually running as Docker containers. So we have container running for the front end over here. We have container running for the back end over here. And the database over here is a managed SQL server. Okay, it's a Postgres flexible server primary and Postgres flexible server read replica. So read replica is like, it is sort of a master slave architecture where this will be your primary server, and whenever it goes down, the request will redirect it to the read replica, because read replica will then become the master. Okay, and there is an asynchronous database sync over there. So these two database have the identical data. Now there'll be network security group attached to each of the tier or each of the subnets. Why? Because we need to control the traffic, like who are allowed to access the public subnet instances and on which port. Similarly, who are allowed to access these private subnet instances on which port. Like this should only be accessed by load balancer, right? This should only be accessed by app gateway, and only the Bastion subnet should have SSH access to these servers, right? So all these rules that we have, these rules will be written in network security group. Now this is also similar to security groups in AWS. This is similar to firewall rules in GCP, right? So that's what we have over here. Now the request will come to app gateway. It will be redirected to one of the available servers in public subnet. Now on these servers we have containers running. So basically the request will be forwarded to the Docker container. Now then the request will be sent to the internal load balancer that you have over here. Okay, and then this load balancer will have rules to redirect the traffic among these two private subnet instances. Again, in the instances we have Docker containers running, and then we have the similar connectivity to the database over here. So all the request will go to this master server over here, or primary server, you can say that. Now, because these servers are part of your private subnet, that means it wouldn't have internet access. So what if you have to install, what if you have to pull some Docker images over here? What if you have to update some packages? How would it get the internet access to it, right? So internet access it will get with the help of Azure NAT gateway. NAT gateway is a service which help you securely connect your private subnet instances to the internet, right? And it the request the outgoing request does not go through the internet gateway, rather it goes through the Azure NAT gateway. So it is a secure way and one of the best practices to secure your servers in the private subnet that you don't want to be exposed over the internet. Because if the request will be going through the public internet, there is a risk of intrusion, there is a risk that someone could intercept the network traffic, right? So that's why this is one of the best practices and secure way of doing that. Now, similarly, we have private DNS zone, which will help you resolve the host name as fully qualified domain name. Okay, and then we have key vault, where all your credentials will be stored and accessed, like your Docker Hub credentials, your PAT, like personal access tokens, and all those things will be here. I've also added container registry over here, but I have used public GitHub to pull and push the images, so that you can also use my public Docker Hub images to perform the demo. But you can change it to Azure Container Registry. Okay. Now, this infrastructure end to end, it will be provisioned through Terraform, because this is day 27 of 28 days of Azure's Terraform series, which is part of our ongoing series for Azure Terraform. And this is a real time project that you can implement. So everything will be done by Terraform, and all the details I have already added in the day 27 folder of the GitHub repository. You will find the link in the description. Okay, so basically this is the repo Terraform Azure full course. And then over here we have, oops, am I sharing the screen or not? Wait. Okay, somehow my screen was stuck, but here it is. Okay, so this is my repo, and then you can go inside lessons folder, and inside that go to day 27. Now over here, as you can see, we have the application code. So this is a backend, front end, infra. In the infra folder, you will have the Terraform specific files. Docker local deployment will be like it will have Docker Compose. Let me show you. In fact, it will have a Docker Compose YAML through which you can access and implement this application locally using Docker Compose up command. Okay, and here are the instructions. So this is the architecture that we have just reviewed. Now, uh, as like if like specific to application, this will be the flow. So we'll have a front end. So this is for the sample application that we'll be using. So we have a front end which is written in Node.js and exposed on port 3000. Then backend which is written in Go and exposed in port 8080. And then we have a PostgreSQL database. Now you can use these instructions to run the application locally, but we'll be using Terraform. So we'll skip this part. Okay, and here are the instructions. So these things we have already discussed. What it will have a VMSS with auto scaling group, application gateway with WAF, deployed in public subnets, two availability zones, and all those things we have already discussed. Now it will have some prerequisites, and if you are following this series, you should already have these prerequisites done by now. Now, what you need to do is, to start with, you can start creating a service principal, or you can use something called a managed identity, or you can use personal user as well for the testing purpose. Okay, so let's start with this. So first start with AZ login. So you log into your subscription. I am already logged in. And then you basically create a service principal with contributor role. Okay, so you need, I believe, contributor role and Azure administrator keyword administrator role, but yeah, so for now let's just add the contributor role and we'll see if we get any error. Okay, so just copy this command, go to your VS Code. Oh, before that I just need to clone the repo, right? So this is the repo code. Copy, me open my VS Code. Okay, and do a git clone. All right, and inside Terraform full course, and then lessons day 27. Go to infra. Okay, this is where you need to be. Okay, now you can run the command that we have copied. Sorry, not this one. Lessons day 27. Okay, and okay, over here. So AZADSP create for our back, and make sure you create the service principal and assign contributor role to it. Now over here, you should add your subscription ID. So let me add my subscription ID. Portal, go to subscription, and here's my subscription ID. Okay, and the Terraform, oops, it says insufficient privileges. Let me try to do AZ login. Maybe I'm not logged in. So let's do that. Okay, retrieving tenant and subscription. Okay, select a subscription and tenant. Okay, let's use. Okay, I think I am logged in. So let's try the command again. Okay, it says role assignment already exists because I've might have created it earlier. So let's copy this. Okay, we'll need it uh, very shortly. So I'm gonna save it somewhere safe. Okay, and let's go back to the instructions. Now over here you can set the environment variable for the authentication, and then you can just do the AZ login with the help of service principal. Okay, so let's copy this, and I'm gonna add it over here where I copied the earlier results. So you should be able to see it. Okay, I'm not sure why I'm not able to zoom in, but like we just have to make these changes. App ID will be over here, and then we have client secret, which is the password. Then we have subscription ID and tenant ID. Tenant ID is over here. Let me copy the subscription ID as well, which is over here. Okay, paste, and let's just set these environment variables. Okay, now what we need to do is we need to do AZ login over here with the service principal, as you can see, and we'll pass username, password, and tenant details with the help of environment variable that we just set. Okay, did it happen? I'm not sure. What's that? Decode. Did I make a mistake over here? No. Okay. Okay, let's try this again. Okay, it is throwing me the error because it says argument expected. Okay, so the environment variables were not set. Let's copy these again. Am I missing a double quote over here? Oh, okay. Because while copying it, I guess this there is a special character at the end. So let me copy it again. Where was it? Over here, I think. Oh no, it's just taking the text formatting. So let me just manually update it over there. Okay, this is fine now, and I'm gonna copy paste all three over here. Okay, environment variable have been set. Now let's just run az login with the service principal. Okay, now I have logged in with the help of service principal as service principal, not as the personal user. Okay, so over here it's good. Now let's have a look at the folder structure. Okay, so let's go back. Let me open the folder over here. File df. Am I in the right folder? I'm not sure. Oh no, it was in downloads. Day 27. Okay, so over here, infra. Come on. Okay, so this is the folder structure. So we have a backend folder. In the backend folder, it's the application code. So we have a Docker file, and what this Docker file is doing. So it is using a Golang image with 1.23 Alpine. It's a multi-stage Docker file. As you can see, we have a builder stage, and then we have another stage in which we are just copying from the builder. Now, what exactly this is, I have already explained this in depth in CK video, I guess day 3. So you can check that out if you want more details on this. If you are aware of it, then let's proceed further. So we are using the base image, then we are setting the work directory to app, then we are copying the files, then we are running the command go mode download to download the dependencies, copying the source code. Basically we are just building an application like how would you would do manually by running some commands. This is what we are doing with the help of Docker file, and it will help you build that Docker image using which we will start the container. Now this will expose the application on port 8080 by running the command backend app in the executable. This was backend. Now in the Docker local deploy, you will have a database folder and a Docker compose file. So Docker compose file will spin up all the containers of frontend on port 3000, backend on port 8080, and Postgres on port 5432 with all the details. So this is for local testing and local um, just to check how your application is working. Okay. Then we have a front-end folder. It will have a similar Docker file and the source code over here, uh, like what we have for the backend one. Okay. So it will expose the container port 3000, and the command is server.js. It's a JavaScript. It's a Node.js application. Now this is where we should be focusing on, which is our infra code or the Terraform code. So it starts over here, main.tf. Okay, so we have a data source which will help us get the subscription details and whatnot. Then we have locals, which will set the resource name prefix. Var.environment, it will take the value from the variable and then it will add a random string suffix to it. Okay, so random string will be a resource over here, as you can see. So random string resource type dot resource name, which is suffix, and dot result, that means the result of this particular resource. Now what it will do, it will create a random string of length 6. It will not have any special character, it will not have any uppercase character, it will have the lowercase characters and without any special characters, and 6 characters in length. So this random string will be added over here in front of the environment. So it will be, let's say, test underscore the random string or prod underscore the random string. Okay, then we have the common tags local, which will merge the tags inside the variable with the environment name. Okay, then a resource group, Azure RM resource group, and this resource group in which all our resources will be provisioned. Now, networking module. So we have created a custom module over here. Custom module, I have created a numerous number of videos on custom modules. In fact, in this series, Azure Terraform, we have a dedicated video for custom modules. So make sure you go through over there as well. But to give you an introduction, what it will do. So you create a separate folder. Okay, let's say over here inside modules, you have created a separate modules for each of the component. Now this module is a reusable template using which you can standardize some things and you can reuse it to create more resources or more uh, like it's a sort of a production way of provisioning the infrastructure. Okay, like you have created a template, now you are asking your team members to use this template to provision the resources. So you have specified certain things in that you cannot override. Okay, let's say your virtual machine should only be using like D2 vs3 type of machine, right? Or it should only have the Linux Ubuntu image. So all those things you can specify in the custom module so that you cannot override it from here. Okay, so the way you write modules, so it starts with the module keyword and then the name of the module. So let's say networking module, and then you provide the source of that module, where it is. It could be on like a Terraform registry, like a remote Terraform registry where you publish it, or it could be locally. Like over here, we have used the locally stored custom modules. Now you provide the path, so it's inside modules and then networking. Okay, so what's there? We'll go through there. But for now, all the variables that module needs, it has to be passed from here like this. Okay, so let's say resource group name, we provide resource group Azure RM resource group, which is this one, dot main and dot name. So similarly, you provide everything over here. So you'll assign every value over here, and then you can use that value inside that module. So where is the module? Go to modules, networking, and then main.tf. Now, whatever we are using, we can directly use it with var dot that name, because we have already obtained those values from the main.tf at the root module. So this main.tf at the root level over here, so this folder is the root module. Even if you don't have any modules in the Terraform code, you always have this root module. Okay. Now, okay. Okay. Now, over here, as you can see, what we are doing, we are provisioning a VNet. So we have an virtual network. We're getting the name of the virtual network as resource name prefix. So remember the resource name prefix, the local that we have created, it has a random suffix plus the environment name, and it is appending VNet at the end of it. So we are just using some best practices, or we are using some nomenclatures. Like we have provided a standard way of naming the resources. Okay, so that's what we are doing. And then location, resource group name, address space. Now this address space is what we have specified in the variable, again var dot vnet address space. Okay, now there'll be variables inside this folder over here. Okay, and then variables at the root level. Okay, so it has all the variables and the default value. Okay, and then let's go back over here. So created the vnet, then we created the public subnet for front end. So we need two public subnets, that's why we have used count over here. So length var dot public subnet prefix. Okay, so what's that public subnet prefix? Let's go back to variable and let's check. Public subnet prefix is a list of string which has two values. Okay, so this is the subnet CIDR range 10.0.1.0 slash 24, 10.0.2 slash 24. Now if we go back inside it, so what it will do, it's a length function that determines the length of the given string. So this variable has two values, right? So the count will be set as 2. Now this particular block will be executed two times to create two subnet. Okay, and this will happen with the help of this address prefix. In the address prefix we are using count dot index. Okay, what we are doing, count dot zeroth index and count dot first index. So first it will do for the first one, which is at zeroth index, and then it will do the second one. Okay, so similarly the backend will be provisioned with two subnets. Then we have two subnets for database. Okay, and then we have a bastion subnet in which where a bastion host will reside. So using bastion is again a best practice. You should not be logged directly to the virtual machine. You log into a bastion machine. So bastion is a jump server, or like an admin box in which your team will have access. So first you go over there, and it's called jump server because now you can jump to whichever server it has access to, right? So this is the bastion subnet, and then we have application gateway subnet in which our application gateway resource will be created. And then we have public subnet network security group rules. Okay, so over here we specify the rules. For example, the security group rule over here with the priority 100, it says any traffic that is coming to any port, source address is internet, through the internet on the destination port 80 and destination address prefix is, so it is allowed HTTP access. So that means our front end server will be accessible over port 80 through the public internet. Okay, similarly we have 443 for HTTPS. We have port 22 which is SSH access. Now SSH access, as you can see, the source address prefix is bastion subnet prefix. That means only the bastion subnet CIDR range should have access to SSH um, into the instance in which this rule has been applied to. Most probably it will be the front end server. Okay, so your bastion host will be only able to SSH into the front end machines or the back end machines. Now this port range is destination port range. This rule is probably to access the services, right? Because those will be the node port service. Now these are for the private subnet. So for the private subnet, only you are allowed to access the private subnet from the virtual network itself. That means it can come from the bastion host, or it can come from the the load balancer, the internal load balancer that we have, or the application gateway that we have, right? So only those services that are part of our virtual network should be able to have the inbound access to this private subnet network security group. Similarly, port 8080 will also be accessed by VNet address space, and outbound access is allowed, like going out to the internet. It is allowed by default. Now, database server, port 5432, this is the port on which your database will be running. Only VNet will have access to initiate the inbound connection to it, and outbound is only to the virtual network. And there is another security group which says um, outbound on 4432 Azure cloud. That means your database will be sending some response back to the server that is part of your Azure cloud address prefix. Then we have Bastion over here. So Bastion will be accessed over port 443 through the internet, and 443 from the gateway manager, from the Azure load balancer, 8085.701 from the virtual network, and so on. So these are just the network security group rules that we have added over here. And then you have the association of network security group with the subnet. So currently we created the network security group, we added the rules to it, but now we have to attach that network security group rules to the subnet. So that's what we did over here. Okay, so we have attached those network security group rules to the subnets. Now network gateway provides outbound activity for your private subnets. So over here, that's your NAT gateway resource, and NAT gateway public IP. That's what we need. And then you associate the NAT gateway with its public IP. This is the association, and associate NAT gateway with the private subnet. So that's the private subnet association. Okay, so that's the networking module. Now let's go back. Then we have Key Vault. Okay, so Key Vault we have created again with the help of a module. Now it will have some basic variables like resource group name, location, resource name prefix, tenant ID, object ID, and it depends on database module, right? So we have set an explicit dependency over here. So once the database is provisioned, only then the key vault will start provisioning. Why? Because in the key vault we are storing the database credentials, but database credential will only be generated once the database is provisioned. So that's why. Okay, so now let's say once that is also provisioned, once your key vault is created, then it will store the credentials in the Azure key vault. Okay, so it will create a secret. This is the name DB host, and it will add the value. The value is coming from module.database.server fqd. So the module that is database, inside the database, uh, sorry. So yeah, so the module that is database, and inside the database server fqdn will be generated once the database will be provisioned. Similarly, the key vault ID will be generated once the key vault is provisioned. So that's all the values that we have over here. And it depends on, again, we have provided the depends on explicit dependency over here. Now that's the DB host secret. Then we have similarly created the DB username secret, DB password secret, and DB name secret. Okay. Then we have also added, so this was not really required, it just I was adding all the database related details in the keyword. So that's why I've added DB port and DB SSL mode as well to the keyword. Now additionally, you can also store your Docker Hub credential in the key vault like this. So you pass it through the value from the environment variable if you want. Okay, and similarly the Docker Hub as well. The next module is database. So again, we are passing all the values from the variables, or some values we are getting from the previous modules, and we are passing it to the database module over here. Okay, and then we have module for DNS. Now we need DNS for our private hosted zone, so that's what we are doing over here. Then we have compute front end virtual machine skill sets. Okay, so we have um, two virtual machine skill set, one for front end and one for back end, right? So this is what it will do. It will check the so this is a flag that I've added, but currently it will just run without it. So the source is by the way, if you uh, are not aware of it, it's a conditional statement. It will check if the var for deploy compute has been set. So it's a boolean, and then it will uh, set the count to 1, else it will set the count to 0, whatever. Now these are again all the values that we have added for the front end virtual machine scale sets. So the important ones are application port 3000. This is the port on which our container will be exposed, and we are using health probe on path slash. So health probe is needed so that our virtual machine scale set will probe the instance, and it will know that when it is healthy. Okay, And over here we are passing the backend load balancer IP, right? And it is dependent on keyword and backend module. Now similarly we have backend, so first backend will be created and then the front end. So then we have backend module. In the backend module we are using application port 8080, and health probe is slash health path. And then we have the database connection because the backend will be connecting to the database, so that's why it is dependent on the database. Okay, so first your database will be provisioned, then your backend, and then your front end, because we need to have database in place before backend, and before backend we need before front end we need backend. So that's how it will provision it. Now the database connection will be used with administrator login and password that will be defined in the database module itself. Okay, and db name and SSL mode, these are from the environment variables. Now there are some additional steps that we need to do to get the required access. So we are setting the secret, get, and list permission on the service principal that we have used. Okay, and basically that's it. That's all the resources that we have. Now once it will run, we have an output.tf which will print out all the values of these variables on the screen once the apply has been completed. So we'll see these values. Then over here in the provider, we have used Azure RM provider, a random provider to generate the random string. And then we have used some additional features for, let's say, key vault, for resource group and virtual machine scale set. It says role instances when required. So it's rolling update basically. Okay. Then all the variables are set over here. As you can see, every variable has a default value attached to it. And what else? There is an environment folder. So currently I have one environment which is prod, but you should have multiple environments over here. So one for test, staging. So these are the things that I've told you, like I'll tell you the things that you can add to elevate it and to make it one big production ready project. So over here in the environment, similar like we have prod, you can add test, you can add dev, and have separate Terraform TF-var files to it. Right. So this TF-var files, it's just a key value pair to set the variables. So variables can be set in multiple ways, and we have seen that in one of the previous videos. So we can set it through environment variable, we can set it through TF-var files, we can set it through the variable files, variable.tf, and then there is a default value inside that, right? So over here, this file is just a key value pair. It will have the environment name and the value. Okay, environment is prod, location is this, secondary location is this, and so on, like all the subnet CIDR range, VNet CIDR range, everything will be over here, right? So this is specifically for production, right? It also has a tag, environment is production. Similarly, you can have for test, you can have it for dev, and then you can also have backend.tf separate for each of the environment. Okay, why we need it separately? Because you would want your infra, especially your production infra, to be kept safe from any accidental changes, right? So you should not have the same level of access in production as of dev or test environment, right? So the best practice is, in the environment folder, keep all the folders separately, and inside the folders you should have tf-var files, you should have backend.tf, and any other variables or any other environment specific file, right? So here's the backend.tf. Currently, I'm not using any backend.tf in this demo. So I'll be passing all the variables from the command line, so that because I'll be passing, Docker personal access tokens, username and password. So I don't want that to be stored in over here, right? So that's why I'll be passing it from the environment variable itself. Okay, so that's, I believe, all the files. So let's go ahead and start with our demo now. So I am inside day 27. Okay, I just need to perform something. And downloads lesson 28. Okay. Now go inside. No, let's not go inside infra because it's part of the command itself. So let's go back. Okay, we have not set the Terraform backend. So this is what we're gonna do. We'll create a separate resource group from Terraform TF state file. It's a best practice to have it separate. Should not mix it with the existing one. Otherwise, yeah, you can try it out if you want, but you will face a lot of issues if you do that. Okay, so I'm gonna create a resource group with the name tfstate-rg, and then create a storage account. Storage account is used to store the container that has your tf state file. Okay, so make sure you update the unique suffix over here to something unique, because your storage account should be unique across all the Azure accounts, right? So let's use Piyush 101. I'm pretty sure no one will be using tfstate Piyush 101 till now, so it should be completed soon. Okay, let's copy the other command. The next command is to create the storage container. So this is where your tfstate file will be stored. Still running. Do we have a storage account already there, or the resource group already there? Let's see. Home and resource group. Oh, did it just create or it was already there? Yeah, it just created. Okay, and then your, let me add the unique string over here as well, so it will contain the storage container. Okay, so now this part has been completed. Let's move forward to initialize the Terraform backend. Now, to like you probably already know that Terraform, we have to initialize the Terraform backend to download the dependencies and to basically initialize the backend. So we use Terraform init. So these are the things that you can pass as the parameter, which is backend config, storage account name, and basically the details of your tf state files, right? So I'm just going to copy this command and I will make the changes over there. Let's copy this, and I just have to update the unique suffix in the storage account name. Oops. Piyush 101. Okay, it should initialize the backend. It has downloaded all the dependencies and all the provider plugins. Okay, let's go back one directory. And now, like, this is what you can do if you want to make any changes to the application code. You can basically build your own container images and push it to your own repository. So you can follow these. I have already pushed my latest front end and back end image to the Docker Hub. So let me just open this. Okay, so I have my back end over here and front end over here. So now I'll just go to account settings and I'm gonna generate a new PAT token. So go to personal access tokens, hit generate tokens. Let's give it a name. Let's call it demo 101, and public read and write. I only need read access, right? Because I'm not pushing any image, it's already been pushed, so that's good. Generate, and you can just either you can do a Docker login and or just copy it from here. So let me show you the other command that I have, and we'll make the changes over there. So over here, what we are doing while applying the changes, we are providing var files as Terraform tf-var, which has production specific variable details, then Docker username, Docker password. So over here we'll provide the pat access that we have, and the front end and the back end image details. Okay, so these I've already set in the variable itself, but I'm just I'm not sure, like when I created this or when my team created this, I'm not sure why did we added it. Maybe we did it for the testing purpose, but that's okay. It's no harm to use it. Okay, so I'm just gonna update the pat token over here. Oops, not this one. Okay, so let me, oh, I have copied it, but okay, it should be over here. Okay, let me copy it. Okay, okay, and Terraform apply and hit apply. And this should provision your, oh, it says subscription ID is required while performing the apply operation. So I believe we are missing a subscription ID field in providers.tf. So this is something that was added in one of the recent Azure RM provider versions. So what you have to do is over here, Azure RM provider, you need to provide your subscription ID. And let me go back and copy my subscription ID. So over here, put your subscription ID. Please don't put my subscription ID. Okay. This is done, save, and let's go back. Let's apply the changes again. And if it start provisioning the resources, then I'm gonna just pause the recording because it's gonna take around 15 minutes ish to provision the resources. So it says 63 to add. There'll be a lot of resources created, and I believe database and virtual machine scale sets, these are the things that will take a lot of time. So just hit yes, and now I'm gonna pause the recording and we'll come back once this is done. All right, after a while, it is completed, and these are all the output variables that we had in output.tf. All the output variables and its values have been printed. So you can check all the things, and what we need is front-end public IP over here or front-end URL. It's basically the same thing. So let's take it, let's try to open that. And here is our application. So it's basically a to-do list or tracker, goal tracker kind of application. So you can add, oops, it's giving me a suggestion, CKAD series next in my to-do list. Maybe yes. And still processing. Maybe the backend containers are slow or still coming up something. Okay, it says goal added. Let's add another goal. Oh, it did not add it actually. Something wrong with the application. Okay, I should maybe wait for a few more minutes. Okay, let's check on the portal if everything is up. So let's go over here. By the way, I wanted to show you one more thing. So if we go to dashboard, oops, not the dashboard. Yeah. So over here, you see, I had to spend $157 just to implement this project because it took me around 3 days to fix all the issues with it, to fix everything. And uh, these resources are costly, especially the Postgres SQL. So if I check view resource, so the managed database that we have, it's really costly and it's gonna cost you a fortune. It's if you don't really destroy it soon enough. So if we do view detail, and basically here is as per the service name. So you see, I been charged $96 for just for the Azure SQL PostSQL database because we are creating it in multi-AZ and with the reader applica. So that's why. And application gateway $35, virtual machine still better $10, but this is what it costed me, $157 just for this project. So I'm gonna destroy it after everything is done. Okay, so I've waited for a few more minutes. Let's try it one more time. So let's add CKAD series. Add goals. Oh, it's working now. Now our backend is up. That's why I'm able to add the values and it is storing in the DB and it will then fetch from the DB. Let's add one more. AWS Terraform. By the way, these will be our two upcoming series. So first AWS Terraform and then CKAD series. That's what I have planned for now. If we remove, it'll remove the records, and that's our application. Okay, now what else? Yeah, I wanted to show you one more thing which I forgot earlier. Okay, so the way it creates the containers is with the help of user scripts inside this, right? So if you can check over here, and inside the compute module, you go over there. Okay, so there is local, that is okay, and then see path to provisioning script. So there is a front end script and then there is a back end script. Okay, these are two shell scripts that I have created, and if you check, it is passing that script over here with some variables, and these are the scripts basically. So this is script. Oh, I think I have already shown this script, but yeah, this script will be called from the compute module, and the variables will be passed with the help of a template file, and then it will provision the it will do all those settings like the instance specific settings, docker installation, running the docker container, fetching the secrets, and so on, right? And very important, this step is very important, otherwise you will end up with a lot of bill. So you need to destroy the infrastructure once everything is done. So Terraform destroy hyphen auto approve and hit enter. Oops. Service principal. I think I might have accidentally deleted my service principal when I was doing some testing in the background. So for now, what I'll do is I'll just manually delete the resources from here. So I'll just go inside the resource group and delete the resource group from here, but don't do that in production, because what will happen if you do that, because you provision the infrastructure with Terraform, and if you delete it from here, it will create inconsistent state file, and then when you try to provision it again in the state file, it is already there. So you will get duplicate resource error, you will get a lot of errors, and like everything will be corrupted, everything will be damaged. Because this is a testing environment, I can do these things, so that is okay. And once that is done, I'll just delete the tf state file as well. Okay, and yeah, it will take some time, actually a lot of time, to delete the resource group, but that's okay. So yeah, that's it for this video, folks. I hope you found it valuable, I hope you found it helpful, and please try to implement this. Please try to create a GitHub repo, a technical blog, and add it in your resume. It will be super helpful for you if you are looking to change the job, or even for the future perspective, even if you are not currently actively looking for the job in the market. It will be really helpful. Plus, I'm sure you would have a great learning experience. If you did, give it a thumbs up and support the channel. Thank you so much. I will see you soon with the next video. Till then, take care and happy learning.